Hi, this is a supplementary math lesson, Algebra 2, Lesson 71, the Quadratic Formula. And just right off the bat, and I sent an email saying, so for this homework today, on set 71, I want you to do practice problem B, number 7, number 8, and number 21, only 4 problems today. I want you to do them in 2 ways. I want you to solve the quadratic equation using completing the square method and using the quadratic formula. Okay, so we've said before, when we have quadratic equations, that's an equation where the variable is to the second power, excuse me, in the equation. It's very problematic from time to time to solve these equations. So we've had 2 methods of solving those equations right now. One of them is trying to factor the trinomial into 2 factors that we can set equal to 0 and find solutions, and the completing the square method. And this is going to be number 3 method, the quadratic formula. Now, the book section goes through how the quadratic formula is derived. It's actually from doing the completing the square method when we have the a quadratic equation with just these variables in it, letters in it, no numbers. So they're doing the completing the square method using a quadratic equation in this form. Okay, I'm not going to have you do that. If you want to go through and do that and go ahead and solve it, you can feel free to do that. We're not going to do that. If you're going to be going on into other advanced math courses, you'll get practice doing that anyway. So this is just a third tool for solving quadratic equations. Now, realize too, when we have quadratic equations, more often than not, we have multiple solutions. It's no longer just one value of x. There's 2 values that x could be. Okay, so simply what we have to do in using the quadratic formula, we have to get the quadratic equation we're solving in the form over here, the proper form, just like we needed to have proper form for the equation of the line. In advanced math, they're doing equations using the proper form for the equations of a parabola. Okay, so we have to, it's the same drill here. We have to express any problem before we use this tool, this third tool to solve quadratic equations. We have to get it in the right format. So I'm going to be doing problem number 7 from your homework today. Okay, so what we're going to do, let's go ahead and solve that using the completing the square method. And of course, the completing the square method is the first step. We have to get it already into this first format. The proper format, the same one that we have to for the quadratic equation. Okay, and for the completing the square method, we need the x squared coefficient to be 1. Right now, there's a 4 in front of that. Okay, so how do we deal with that? We divide out the 4. Every term in the equation, it comes to x squared minus 1/2 x equals 3/2 equals 0. Okay, we keep those first 2 terms. We set up a parenthesis. We're going to force in a third term, so we send that other term to the other side. Okay, what is the term that we use to force in there? Okay, we take 1/2 of the middle term, so 1/2 times minus 1/2, okay, would be minus 1/4, and we square it. A minus 1/4 times a minus 1/4 is a positive 1/16. That is the term we force into there. Okay, so we've added a 1/16 there. We must add a 1/16 to this side. So this is part of the work. I want you to solve these using both methods. All 4. You only have 4 problems. You have to solve them twice though, using different methods. But we're going to go through almost half of your homework here on the video. Okay, so what does this allow us to do? It allows us to factor this trinomial into an x minus 1/4 squared, okay, equals a what? Okay, well, this turns into, we need to get this into sixteenths, okay, so we'll multiply by 8 to get sixteenths. We'll multiply this by 8, it gets 24 plus 1/16 here, okay, so that gives us 25 sixteenths. Okay, so what do we do to solve, to get rid of this square term? We take the square root of both sides. That leaves us x minus 1/4 equals, this is the step where we put in that plus or minus sign, okay? It equals the square root of 25 over 16, but we can recognize that we can take the square root of that. The square root of 25 is 5. The square root of 16 is 4. Oh, that's great. We've gotten rid of our square root over there. Now all the time that happens, as you've noticed. Sometimes we can't take the square root of the number and then it remains, okay? So then what do? We just simply take x, we move the quarter to the other side, minus 1, or a positive 1/4 plus or minus 5/4. Okay, then what do our solutions become? X could equal 1/4 plus 5/4 is 6/4, or reduce it to 3/2. 1/4 minus 5/4 will be a minus 4/4, or that reduces to 1. Okay, so that is our solution, our two solutions using that completing the square method. Now let's hop over and do the same thing for using what they call the quadratic formula. We call this a quadratic equation. Okay, we call this the quadratic formula. It solves for a quadratic equation. Okay, x is going to equal, just like we did over here, and I'm going to back up, x equals these two solutions. Okay, x is going to equal a minus b. What does b stand for? It stands for the number associated with the x term. What is it? It's minus 2. Okay, so it's going to be minus 2. Then we're going to do a plus or minus. This is just plugging in numbers to the equation, to the formula, I should say, to solve for x. It's going to be a square root of b squared. Well, what is b again? It's minus 2 squared minus 4 times a. A is the number associated with the x squared term. In this case, it's 4. Times c. What is c? C is the constant at the end. What is it? In our equation, it's minus 6. We attach that sign to it, okay? Minus 6. And when I'm substituting in minus numbers, I always like to put them in parentheses to stay out of trouble, okay? Then I'm going to divide it by 2 times a. Again, a is 4, okay? So what does that equate to? It equates to a minus times a minus 2 is a plus 2, plus or minus, under the square root symbol, what am I going to have? A minus 2 squared is 4. Okay. 4 times a minus 6 turns out to be a positive 96. Divided by, and I'm going to shorten my square root symbol there, divided by 8. Okay, what does that leave me? Well, I notice this combines into 100. I can take the square root of 100. 4 plus 96 is 100. Okay, the square root of that is 10. It leaves me a 2 plus or minus 10 divided by 8. Okay, well, what does that leave me? And I'm going to go ahead and erase a portion of this completing the square method to get our solutions. That gives me an x equals a First solution, 2 plus 10 is 12 divided by 8. 12 divided by 8 reduces to 3 over 2. Okay, that's one solution. The second solution, 2 minus 10 is minus 8. Minus 8 divided by 8 is a minus 1. So we see, using that method, completing the square method, it comes up to the same solution that we did with the quadratic formula method, I should say, comes up with the same solution as the completing the square method. And of course, I said at the beginning, the quadratic formula is actually derived from the completing the square method. It's just that they used A, B, and C in the equation to come up with this formula to plug into, okay? So, but I want you to be versed in either way, because I'm not sure which one you would like to do better. You might prefer one method over the other. Go ahead and use that, okay? They're effectively the same method. This one kind of shortcuts right to it, so all that's involved is math. Okay, this has a little bit more steps to it, but maybe you're more familiar with this, so it's up to you what you want to use. Let's go ahead and go to question number 21. So there's a quarter of your homework done for the day. Okay, 21. Now they say to use the completing the square method to solve that problem, but I want you to do both. Okay, so do it by completing the square. Let's go ahead and use the quadratic formula to do that. So they give us an equation of 3x squared minus 2x plus 5 equals 0. The first step, we need to have it in the proper format, which they already nicely did for us, okay? So then it's just plugging in. X will equal, okay, it equals a minus b. What is b in this case? In this case, it's minus 2, okay? Plus or minus the square root of b squared, again, is minus 2. Sorry for that. Minus 2 squared, going to be minus 4 times what? Times a is the first term. In this case, it's 3. 3 times what? Times c. In this case, it's plus 5. Okay. And then in the denominator, it's going to be 2 times a. A is, again, the first term, the first coefficient, 3. Okay, let's go ahead and do that math. Minus 2 times a minus is a plus 2. Plus or minus under the square root symbol. What do we get? We get minus 2 times minus 2 is 4 again. Minus 4 times 3 is 12. 12 times 5 would be 60. And it is a minus symbol. Okay. 20 times 3 is 60, right? And then dividing by 2 times 3 is 6. Okay. What does that equate to in here? So we have 60 minus a minus 60 plus 4. We get a 2 plus or minus in the radical. Now we get a minus 56 divided by 6. So we notice we have a minus under a negative sign under our square root symbol. Okay, we're going to boot that out of the radical with our Euler's notation for complex numbers. Okay, I'm going to go way over to the side here. So our expression becomes 2 plus or minus the square root of 56 times an I, which stands for the square root of minus 1, divided by 6. Okay? So that just leaves, can I separate my 56 into two other factors, one of which I can take the square root of. I don't know, I'm just going to analyze it real quick. Okay, what do I get? I get a 2 and a 28. I get a 2 and a 14. I get a 2 and a 7. Okay, so that shows me here I can divide 56 into the numbers 2 times 2, 4 times 20, 4 times 14. Okay, I can take the square root of 4. Okay, it is 2. So then I can replace that with 2 plus or minus 2 square root of 14 I over 6. Okay. I can simplify that further because I can reduce these two fractions here. Okay. That equals 1. In other words, I can put that 6. What am I doing? I'm dividing the fraction, putting the common denominator under each portion of the fraction. It becomes 1 plus or minus the square root of 14I over 3. Over 3, because the fractions reduce to 1/3. Okay, and that is my solution to the problem. So that's half of the solution to that problem number 21. The other one, you need to do it by completing the square. Okay, so as we go on, we'll start dropping off the completing the square methods if this is easier to you. Okay, and we'll start going with the quadratic formula to solve these. Okay, now if you find the completing the square method simpler or more easily understood, you want to keep doing that, that's fine. It's going to be a little bit more complicated as you go forward with other problems. I don't know if we'll actually get into that this year. This is generally a simpler way just to plug in the numbers and solve for it. It comes up with the same solution. But for your homework today, I want you to do both. We only have 4 problems. Do it 2 ways on each problem. We've done almost half of that homework here on the video lesson. So I hope that helps. Shoot an email with any questions or a text message. So long for now.